With that, we're going to get started on our next session. This one is about the gateway and industry innovating solutions. This next session is once again generously sponsored by our all-day sponsor, BWX Technologies, as well as Aerojet Rocketdyne and Zinn Technologies. So please join me in welcoming our moderator, Michael Barrett, Director of the Spaceflight Systems Directorate here at NASA Glenn. Mike, in that role, Mike is responsible for planning, organizing, and directing the space technology development and missions assigned to the center. Before that, Mike was chief of Glenn's Power and Propulsion Project Office and project manager of the PPE, or Power and Propulsion Element for the Gateway. In that position, Mike was responsible for a cross-agency team of 120 personnel and the management and technical oversight of the $375 million PPE development contract with Maxar Technologies, our lanyard sponsor. So with that, turn it over to you, Mike. Thanks.
Let me extend a personal welcome and thank you for everyone that's here for this year's John Glenn Memorial Symposium. At NASA Glenn, our portfolio is spread roughly 50-50 across aeronautics and space. And so in the space portfolio this year, there's over 100 projects. They total approximately $450 million. And I can tell you that the space segment is extremely diverse. Those projects run from a handful of folks that might be doing materials research in a lab on site at Glenn, up to a project that we lead with 150 plus people across multiple centers, coordinating across multiple companies. Another distinguishing characteristic of this space work that we do is our customer base. We do significant work for all 4 space mission directorates. Some quick examples: for the Science Mission Directorate, we host the Radioisotope Power Systems program, the RPS program, as well as the Planetary Exploration Science Technology Office, or PESTO. For STMD, we are leading the FSP, or Fission Surface Power Project, as well as the Solar Electric Propulsion Project, which includes the AEPS thruster, which I'm sure we're going to hear a little bit about, and is in the chamber over on site right now. For SOMD, we're leading the Communication Services Project. That's in the SCAN program office. And then for ESDMD, we host the Integration Office for the European Service Module, as well as the Power and Propulsion Element. We lead and manage that development for the Gateway. That's something that's near and dear to my heart, so I'm particularly excited about the panel this morning. So let me go ahead and introduce you to our panelists. First, we have Gabriella Blackner. Gabriella is the Chief Engineer of the APS Hall Thruster Program, working through production and qualification testing in support of the Gateway mission. And side congratulations, right? That QM1 thruster just recently completed acceptance testing, so TRL-6 officially now. Right. Previously, she worked in commercial aerospace services and human spaceflight with the Orbital Science Corporation and Blue Origin. Her passion for human spaceflight was ignited in high school by the first flight of Spaceship One, and she's honored every day to continue to work toward the expansion of humans in space. Second panelist here, Chris Coker. Chris has worked in the space industry for 24 years in various technical and executive leadership roles. Prior to his current role, Chris served as the Vice President of Maxar's Subsystems Engineering and Manufacturing Organization. And aside for Chris's boiler up, I think there's a master's degree in there somewhere from Purdue. Let's see, our third panelist here, Rick Mastracchio, is the Director of Strategy and Business Development for Northrop Grumman's Human Exploration Operations Unit. He's held previous positions as a program manager and as a director of Cygnus Operations. Prior to joining Northrop Grumman, Rick spent 20 years as a NASA astronaut, and it was indicated such like a footnote on what you sent me. I had to look it up just to get something else there right. So Rick had, during his career as an astronaut, 9 EVAs for more than 53 hours, which still ranks 13th overall in human history. And I just think that's pretty cool to pilot your own spacecraft, essentially, right, for that many times out. So thank you for that astronaut service. And then finally, we have Chris Sheehan, Vice President of Engineering at Zinn Technologies. Chris has been at Zinn for 20 years, serving as an engineer, project manager, director, and VP, supporting ISS research, payloads, and commercial space endeavors. And for Chris, I'll give an OH. There we go, okay. I'm not an alum, but my daughter is. She'd be glad I used that. All right. So we're going to start out here with about 5 minutes for each panelist so that they can tell you what they're working on or with or for related to Gateway. So we'll go ahead and start with Gabriella.
All right, good morning. All right, so as Mike has already mentioned, I work as the chief engineer on the AEPS program, supporting Gateway and getting out to the moon. And I'm outranked here, so the people on this team know more about this than I do, and probably most of you are very familiar with this, but just for background information, the AEPS thrusters will be used on the PPE spacecraft to get Gateway out to the moon, and we'll be spiraling out from Earth orbit out to NRHO and doing station keeping, about 15 years of support in lunar orbit. And electric propulsion is one of those technologies that enables us to provide more payload to the surface or to your mission, about 40% depending on your launch duration or your mission duration. And so EP is an excellent application for Gateway, and we're really excited to be flying on this mission. A little bit more about the APS thruster itself. It used to be a system, so that's why there's the word system in there. At the moment, we're only providing the thruster to the Gateway mission, but we also do provide at Aerojet Rocketdyne a system that includes the power propulsion unit and the xenon flow controller. But the hull current thruster itself, TRL-6, so we've just finished acceptance testing on that thruster at Glenn Research Center in VF5 chamber, and we're about to start pumping down and get the thruster back to Redmond to do final functionals. So that's very exciting. We got some new data, performance data, stability data, so great to look at that for the first time on the flight-like unit. It's a magnetically shielded electrostatic xenon thruster, and it produces about 12 kilowatts worth, or uses about 12 kilowatts worth of power at 600 volt set point. We produce about 590 millinewtons worth of thrust, which is all of 2 quarters put together. And for those people in the chemical world, you think that it's very, very low. But of course, the strength of EP is in its specific impulse. And when we apply that specific impulse over long durations of missions, we save a lot of propellant and therefore allow more payload. So EP is great for something like Gateway or going out to the moon and Mars. And we also at the AR company continue to develop the system to support electric propulsion. So the power processing unit and the xenon flow controller, which all work together in correspondence to actually power the thruster and get it out there. And we are continuing to do development testing on those units, bringing it up to TRL level 5 and 6 in development test and eventually in flight applications. So as far as the development goes for APS, we have completed development testing. I started on the program when we were in the middle of development testing, so it's great now to see the thrusters in their flight configuration going through acceptance testing for the first unit. And we did demonstrate in development testing that the performance is very repeatable, it's very robust, it's something that we can rely on data-wise. And when we applied our models and tried to predict what flight units would look like, they were very close and within orders of degrees or so as far as like thermal analysis goes. So that's very gratifying to see once we have the flight units up there and their data. And then, of course, the milestone of getting our qualification testing started at GRC. You can see the thruster in the chamber there. It's a very beautiful picture, I think, to see that. And the thruster firing at 12 kilowatts on the other side. The blue plume of xenon, ionized xenon. It's always a great thing to see when it starts up. The thruster started nominally without issue and continues to met all of our performance requirements. So very exciting to keep moving forward on that. And then as far as the future goes for AR and how EP and electric propulsion starts informing other technologies that will enable us to get more payload out to Mars and other planets and long duration missions, is the future nuclear electric propulsion technology. So you can combine, for example, the APS EP system technology with its thrusters, its PPUs, the XFC, the flow controllers and propellant tanks, in addition to NASA's investment and AR's investment in fission surface power. And you can combine those to really start to develop the technology of NEP, essentially using nuclear thermal energy to convert into electricity instead of solar energy, which just allows us to get into the higher reaches of of higher power applications, of course, more payload to your mission. And you can also decrease mission times because of that and transportation time. So really exciting to see our thruster continuing to develop its flight applications on Gateway so that we can keep pushing into the higher power regions of electric propulsion.
Great, thanks. Chris, go ahead.
I just hit the arrow.
That one?
Yeah.
Oh, here we go.
Here we go.
Oh, you're
Okay.
in the opposite direction.
Yeah. All right, there we go. Hi, everybody. So we at Maxar are very proud to be NASA Glen's partner on the Power and Propulsion Element project, the PPE, because in aerospace we must use acronyms if at all possible. That's an unwritten rule that I've learned in my years in the business. PPE is a once-in-a-generation project, and it's a source of pride for those of us at Maxar working on the program, as well as for Maxar as a whole. PPE is the most powerful solar electric spacecraft that we have ever built. And for Gateway, it serves as the power plant, as the engine that keeps the station in the orbit that it needs to be, as well as the communication system between the station back to Earth and between the station and the moon. So the power system shown here highlights the rollout solar arrays, and in the diagram here we've pointed them out. And the solar arrays provide over 60 kilowatts of power to the spacecraft. The solar arrays are manufactured by Redwire Space in Goleta. And the rollout solar array is a great example of the government's public-private partnership approach with small businesses. Many years ago, the government realized the potential of the rollout solar array technology. And at Maxar, we realized the potential of its application for our commercial communication satellites. So while the government was working with deployable space systems, as they were known at the time, we were also working closely with them to commercialize this technology. So when NASA awarded us the PPE program, we came to the table with a great deal of knowledge in how to implement this technology on complex spacecraft platforms. And so as a result, the innovation that PPE provides is taking that technology to the next level at spacecraft power levels that are order of magnitudes higher than what we provide on our legacy missions, to the order of 3x, 4x higher. The propulsion system is the engine that takes the Gateway from Earth to the moon and also keeps the Gateway in orbit once it gets to the moon. And the propulsion system consists of the EP thrusters that are highlighted here, as well as components, tanks, valves, PPUs inside the spacecraft. And our industry partners have advanced electric thruster technology. Maxar has flown solar electric propulsion on our spacecraft commercially for almost 20 years. In the past decade, nearly half of our commercial missions have utilized solar electric propulsion in some way. But the innovation, the technology coming from our industry partners is bringing more powerful and more efficient thrusters to market. And so the innovation in the propulsion system is integrating that technology into a spacecraft platform that is usable across many different mission sets. And then the communication system, which consists of the antennas highlighted here, as well as comm equipment inside the spacecraft. It provides the communication links between the spacecraft and the Earth, between the spacecraft and the moon. And on our most of the spacecraft that are currently in orbit are either in the low Earth orbit or in the geosynchronous orbit, being about 1/10 of a way between the Earth and the moon. So the innovation that the PPE is providing here is providing reliable, consistent communication over that long distance between the Earth and the moon over a 15-year period. So next we have a short video here highlighting some of the accomplishments of the PPE program over the past year. Okay. So as you can see, we're producing flight hardware. This is becoming real. PPE is no longer a concept. It's real, it's tangible, and it's happening. Our structural cylinders are completed, our structural panels are completed, and we're in the subsystem testing phase there. We continue forward with propulsion testing, building on the successes of the past year, and we expect to be in propulsion subsystem manufacturing later in the year. And we're working, our teams are working together to get to system CDR also before the end of the year. So, this is an exciting project on an exciting program, and Maxar is very proud to be working with NASA and our industry partners to make it a reality. Thank you.
Great, thanks, Chris.
Well, thank you. Let me also first say thank you for the great videos and graphics, because I don't have any now, but you've seen a lot of pictures of the HALO module, right? The Habitation and Logistics Outpost. So I'm Rick Mastracchio. I represent Northrop Grumman Human Exploration and Operations Group. So we're a relatively small group at Northrop Grumman our biggest program that we've been working on for the last 10 years is we deliver cargo to the International Space Station with our Cygnus spacecraft. So we've been doing that for coming up on 10 years in the fall. Right now we're getting ready to soon be launching our 20th mission. And from that technology, the fact that we have a production facility building our Cygnus spacecraft, NASA chose us to develop the Habitation and Logistics Outpost, kind of that habitat for a crew-tended space station in cislunar space. So several years ago, NASA assigned us to go off and build that. We've been working with industry partners, with Maxar and with NASA and others to get that. We've completed critical design review just a few months ago, and similar to the PPE story you just heard, we do have hardware. Over in Italy, the primary structure is undergoing the final welding. It will be completed in a matter of weeks. And of course, then we'll go into the full integration and test phase of the program. So it's all moving along. Of course, let me just talk a little bit about what HALO is. It's very different than the International Space Station. I got a lot of International Space Station experience, maybe the audience does too, but ISS is a permanently crewed vehicle, very accessible in low Earth orbit. HALO and the Gateway in general are going to be a little bit different. It's more to be a crew tended. In other words, the crew's going to go and stay for shorter periods of time. It's not right now being meant for permanently crewed missions, but the missions will grow over time from what NASA tells us. It also has a little less accessibility right now, but over time, the Artemis program will improve the accessibility to the Gateway. But it's more than just a path to cislunar space. It obviously allows missions to the surface of the moon and then eventually onto Mars and beyond, we hope. So it's a very different mission than the ISS, but it has a lot of similarities. And so we're building upon those similarities to make the program very successful. Thank you. What do you need? Just a pointer?
Chris.
Hi there, Chris Sheehan, Zen Technologies. I have to start by saying we are now a wholly owned subsidiary of Voyager Space. That just happened this year. That's very exciting for us. Our acquisition doubles their headcount to about 600 people, and it's a portfolio of about 9 companies that all have unique capabilities in the commercial space area. So we're very excited about that. And we are very honored to be here today and be a sponsor here at AAS. I've been at Zen for 20 years, and somebody told me the other day that's almost like a whole career, and that was reassuring that I can still have one of those, I suppose. But we started a lot of work with NASA Glenn, at the inception of Zen, and Zen has kind of gone through a couple name changes. About halfway through that timeline you're looking at, you start to see things that are not Glenn-centric. All these things could not have happened without a steady relationship with Glenn Research. So, certainly we appreciate that. But we were there developing payloads for Mir, for Station. We started to branch out into commercial power. So we've delivered some units for the Dream Chaser Tail 1, which will be visiting Armstrong Test Facility here, I think, sometime in the next month or so. We additionally have collaborations with Aerojet Rocketdyne, and we supplied the power processing unit for Next-C on the DART mission, so that was very exciting for us as well. Some other things that, we obviously are supporting HALO, so I'll talk a little bit about how this collaboration with Glenn evolved into sort of a product line for us, for lack of a better term. Here's our footprint. There's nothing worth going through in much detail here except for, 12 o'clock is Glenn. In the last 10 years, we have delivered flight hardware to Northrop Grumman, Maxar, Aerojet, Sierra Space, and Voyager is our current sort of parent company. We are working with NanoRacks and other entities like Airbus to develop a commercial space station, which I'll talk about in a moment here. Yeah, so about 400 experiments we've put up over the lifetime of, I guess, LEO experiments. So I think that talks to the strong collaboration with Glenn Research. The FUR and SIR facilities were done by us. We still maintain those. And then, of course, numerous glove box experiments and temporary installs. In the upper left-hand corner, you see SAMS. That's sort of where we started with acceleration measurement and what sort of evolved into the product that we are providing for HALO in structural health monitoring. Sort of the exciting news here, in addition to this acquisition, we do have a significant amount of work on this commercial station endeavor. Voyager, NanoRacks, and Airbus are sort of joint developing this. The Ohio State University is doing the ground analog section. Dr. John Horak is sort of leading that effort. This is a privately financed endeavor. We're moving towards the end of the decade, hoping to have something together out there to sort of dovetail with the retirement of station or however that ends up. So this is very exciting for us. It means also bringing a lot of jobs to Ohio, which is also something we're very proud of doing. So these are just some of the large power missions that we've powered large missions. Like I said, NextSea, Dream Chaser. We got folks out at the facility now. HALO, and I was actually out at Palo Alto. I got to see OSAM-1 at your Maxar facility in EMI testing, and the NASA software SQA guy came up and said, "Oh, I remember you from 10 years ago. You gave us one of these for MMS. You must have sold hundreds of these." And we said, "Well, this is actually the second one we've sold." But so it is a product line, and in general, spaceflight hardware niche systems require a lot of development and sort of repurposing, right? So to that point, this is sort of how we're serving Gateway HALO right now. Really starts at what we did with space acceleration measurement back in Mir and Space Station. So, we developed this system to basically characterize vibroacoustic environment for researchers so they could timestamp if they saw an event. Oh, what's this data glitch here? We can go and look at, there was a docking event or a reboost event. That led to work with Goddard Flight Center. We've provided an inertial measurement system for the magnetospheric multi-scale mission, which is still flying and holds 2 Guinness Book of World Records. So that sort of was the next step for us. It was, the sort of Class D payload type facility thing on ISS to a Class AB mission critical piece of hardware, which obviously we had to grow and get better with that type of responsibility. And then that design was leveraged into basically a structural health monitoring system for Gateway, which is where we are here today. So yeah, thanks. Very, very happy to be here and looking forward to the discussion.
Thanks, Rick. And I knew you were going to talk about microgravity experiments, so I didn't mention that in my opening comments. Obviously, a big part of our portfolio at NASA Glenn, and a special thanks to Rick for Cygnus, because not only do we do the work on ISS, but all the Sapphire experiments that we ran on Cygnus. Anyone that ever a few years ago heard the NASA intentionally lit the largest fire in space, right? That was a combination of work here at NASA Glenn, but executed on Cygnus, right, prior to return. So thanks for that. All right, so we'll jump right into the questions. The topic here is about industry innovation and commercialization, that kind of a bent on it. So I've got a couple prepared questions, and then we'll go down and then turn it over to questions from the audience. But our first one here, and I think we'll just start, Chris, if you're okay, we'll start down there and work down the line on the way back. But first one here. As humanity's first space station in lunar orbit, how might Gateway's capabilities support your company's cislunar commercialization plans?
Right. So as a demonstration platform, we've got a number of technologies in sort of human exploration, that might serve as a good demonstration. We've certainly done multiple rounds of exercise countermeasures developments and sort of blood analytical tools and things like that for ISS. There are new opportunities, obviously, in a platform like this. I think there's, EP opportunities potentially for some demonstrations there. And I think some of our sister companies, Space Micro being one of them for Space Comm, potentially, there could be some either subsystem or demonstration, capabilities with that platform as well. So we're trying to look out and see, what these opportunities are. And now we obviously have a much larger funnel with Voyager Space, and we're just excited to be able to, try to fill in those gaps as we see them.
Great, thanks. Rick, what about for Northrop Grumman?
Yeah, thank you. As I said, we've been operating the Cygnus spacecraft for 10 years now, where we're delivering logistics to low Earth orbit very reliably and on a regular basis. Now with our HALO experience, where we're actually building a habitat, designing and building a habitat for cislunar space, we get a couple additional skills to our skill set. We get additional habitation skill sets, and we also know how to design and develop and now operate a spacecraft in cislunar space. So what we'll do is we'll take our logistics experience and we'll look at how we can apply that to cislunar space, whether it's delivering logistics to cislunar, whether it's delivering additional habitats or modules or science out there to that region of space, and then beyond, of course.
Great. Chris?
So we see Gateway as the first of many deep space service stations. If you look at the space infrastructure that exists today, most of it is in low Earth orbit or it's in geosynchronous orbit. Well, Gateway will be the first piece of critical space infrastructure that is designed and will operate beyond that in lunar orbit in deep space. So we're going to learn a lot from Gateway and the capabilities that it provides. We're going to learn a lot of science around the cislunar environment. We're going to learn how to live and work in deep space. And we're also going to learn some of the unique benefits of the cislunar environment. There are use cases, there are business models, there are commercial opportunities that we haven't thought of yet that are going to be unlocked because of Gateway. And so we view Gateway as the cornerstone of the future thriving deep space economy. And as this deep space economy grows, that's going to drive the need for more service stations, for more PPEs to provide logistics support between the Earth and the Moon, as well as ultimately between the Moon and to Mars. So that's where we see it.
Great, thanks. Gabriella?
Yeah, so at AR, we have nearly 20 years worth of SEP, or solar electric propulsion development, but not at this power level. So the 12 kilowatt power level is a milestone, and I think in the earlier presentation on the X-Wing, there was a lot of discussion on how modeling and analysis really drive down a lot of that risk. With electric propulsion, there are still a lot of unknowns about the physics of how an AP thruster operates. And if you compare analysis outcomes to lab outcomes, they typically don't 100% align, and we learn things. So we learn things on the ground through development tests, but we will learn things through flight, and especially in deep space applications. And so that will help us further develop this technology and get that in-flight experience, especially development of a system level with PPU and XFC in the loop. And that allows us to go on to further developments in higher power, 300 kilowatt buses to high power missions. And so that's where we see Gateway just being a large technology demonstrator for us and getting that flight experience so that we can keep pushing on power capability.
Yep. Thanks for that. When you said that, it reminded me 10 years ago when we were talking about using solar electric propulsion on PPE, or we didn't call it PPE yet, but we had to still explain to people how it worked. And now the default, people just assume it's there. It's 15 years. We're going to fly humans, and right. And so I think it's important that we're not afraid to say there's still some demonstration activity here, right? We certainly have designed for the missions that we need. And we know that it will be safe, but we're going to learn a lot, right? So it's a good point. Thanks. All right. Second question here. What are some ways your work for Gateway enables or assists your other business endeavors? And we'll just start with Gabrielle and go the other way this one.
Sure. Yeah. Long-term goals for AR, of course, is developing our infrastructure in space, and EP actually goes quite well hand in hand with higher power ground launch operations, because EP allows more payload, so therefore you could potentially put more mass into space for less propellant on board, which goes really nicely hand in hand with our higher chemical engines that we sell at AR. So keeping, SLS working and that infrastructure and getting a rendezvous point out in the moon for many of our AR technologies on Orion and our chemical engines as well as EP. So there's a lot of symbiotic relationship between Gateway and our other commercial enterprises at AR. And it allows us to go for longer distances, higher payloads, and really explore that space and provide more infrastructure to support it.
You mentioned more mass, right? So for the folks that don't know, because when we live it every day, we don't necessarily think about it, but PPE and Halo are launching together. They're co-manifested. That wasn't the original plan. They're going to have separate launches. You can only do this mission because of electric propulsion. You cannot do it with single payload launch and then still make it to cislunar without the high ISP of the EP systems. So, yeah, good point. Chris?
Yeah, more power and better efficiency are sellable benefits to all of our customers, government customers as well as commercial customers. Going to talk to the customers with the message of more and better is a great message to have. So the PPE developments are being done on our legacy Maxar 1300 platform. It's the same platform that our commercial customers have used for decades. We have 90 of them currently in orbit. So as you think about how this technology, how these advancements are taking place, there's a direct applicability to Maxar's core business as it is today. Another example is with we've talked about the commercial LEO destinations. So for the primes there are focusing a lot of attention on speed and on safety for obvious reasons. So for a prime for whose business model, business plan, the time to market is important, and flight heritage is important, and design maturity, we can certainly be of value there.
Great, thanks. Yeah.
Yeah, for the Halo module is basically a habitat that is the core habitat for the Gateway. So what we at Northrop are looking at is, as Chris talked earlier about the commercial destination that Voyager Space is working on, Northrop Grumman is also one of the companies studying commercial destination free flyers in low Earth orbit. So we're looking to bring that Halo module, that small habitat, from cislunar space in kind of using it as the base module of a commercial destination in low Earth orbit. Combined with our Cygnus experience, we're looking at that. We're studying that with NASA for the last couple of years now.
Great, thanks.
Yeah, and just from a subsystem provider, we've never been busier answering RFQs, RFIs, RFPs from folks that have heard we're supplying structural health monitoring capabilities. We're also doing some smoke detection for Halo. It's really been sort of almost like a really strong advertising element for us to say, hey, this company is doing something with Halo, these technologies. We're also looking internally to spin some things off from our legacy acceleration measurement, some of the, the developments we've seen in rad-tolerant chips and things. We've seen whole markets really kind of come maybe out of these endeavors where we're obviously satisfying a requirement for NASA, but there's products that are coming up and being asked about sort of almost every week.
Great. All right, thanks. So I've got one more question, then we'll open it up to the audience. But first, this one is a two-parter. It's a little spicier, so I'll let you you decide what order you'd like to answer it. To date, in Gateway's development, what has NASA done well in its commercial partnerships on the program? Going forward, what could NASA do better to benefit both NASA and its Gateway commercial partners?
You want me to start?
Whoever's first.
I mean, we have no complaints. I think that...
Well, we should finish with you, then. That should be okay, right? Yeah.
I mean,
Okay.
the good is obviously that this is happening, right? I mean, that's fantastic. And like I was saying, the phone ringing off the hook at a small company like us is really this pipeline through ESA, through Maxar, through all these different companies. Hey, Zinn does this, that, the other thing. I was talking to somebody at the EP branch the other day, who I won't reveal his name, but he said if we could just get rid of two things, we could accomplish a lot. And those two things are contracts and requirements, right? So obviously those things exist for a reason. They're very important, but I do see an opportunity, maybe, and maybe it's separate but related, like with the CLIPS model, where NASA's not imbuing 1 billion requirements on how you get to the moon, but they're saying, okay, you got to be safe. All right, we have to have some confidence, some level of credibility here. But maybe opening that, okay, show us your capability, and maybe to use this platform, it's not you need to comply with 7,000 requirements documents, but you have some other method. I see that as maybe an opportunity for more throughput, for more innovation from commercial industry.
Is that the good or the bad?
I can't tell.
So, NASA, I've got a lot of respect for NASA and what they've done. I worked almost 30 years there. But on the International Space Station, in my opinion, one of the greatest achievements in humankind. And the Gateway, I think NASA's doing a lot of things really well. The partnerships they're forming with industry, as you can see some of them up here and beyond, and then also the international partnerships. So when you bring a larger group of organizations and countries and companies together, obviously you could pool those resources and get a lot more accomplished in the overall goal of exploring cislunar space, the lunar surface, and beyond. Now, building a permanent gateway in cislunar space is a lot harder than it sounds, and so not everything is as easy, obviously. We talked about, we know how to work in low Earth orbit. Industry knows how to do that. NASA knows how to do that. We still have yet to understand the specifics of how to operate and design for cislunar space and the lunar surface. We know the environment, but we don't know how to operate there in an efficient manner. We just haven't proven it yet, right? We've all talked about that. We're off testing, and we've got a lot of lessons that we will learn in the future. So there's a lot of technical risk there. The other part of that is that there's limited access to cislunar space right now and the lunar surface. So that makes commercialization of those areas quite difficult, or challenging at least. So I think NASA has to really think carefully about their acquisition strategies for the various missions and vehicles and services they're looking for. Some types of acquisitions will not be as bring as many potential bidders as other types of acquisitions, is what I'm trying to say. And NASA wants a lot of competitors. They want a lot of people bidding on their services and vehicles, because that brings their prices and risk down. So that's all I'll say. Thank you.
Thanks.
Yeah, so Maxar was awarded the PPE program because of NASA's focus and emphasis on this commercial partnership approach. NASA is trusting a non-traditional commercial provider with building and providing half of a human-rated deep space outpost. And when I say it that way, it's a very profound statement, and it really reinforces NASA's commitment to this procurement model and to this approach. What NASA's done well in partnering with us on the PPE program is tailoring their requirements to commercial practices, commercial designs. Whenever we've found a gap between how we've done things in the commercial world that's proven to work compared to how NASA traditionally has done things, NASA could have respond to that and say, redesign your entire component or re-engineer your entire process. They have not done that. They have worked collaboratively with us to find inspections, for example, or some tests we can run to prove why the commercial process or the commercial design works. From day one, they have done that collaboratively with us. What NASA could do better, I would say, moving at speed to unlock the full benefits of commercial practices is something that I would identify. Now, again, from day one, NASA has asked us for feedback. They have listened to our feedback, and we see movement and progress in the right direction. But it's a balance. And as a point of comparison, it's not unusual in the commercial world to see a turnaround from program award to launch on the order of 2 to 3 years. So that's the potential of commercial practices in the commercial model. Now, on a program like PPE, there's a balance there. And NASA is working with us to strike that right balance. We've seen progress both on technical decision-making as well as non-technical decision-making speed, but I think there's further progress that can be made there and further benefits that can be derived.
Yeah, I think firstly, Aerojet is so incredibly proud to be part of the Gateway mission. It is a huge endeavor, and it's something that our teams have been working on, some of them since the beginning of the contract, which was 6 years ago now. And So 6 years ago, we started as a system that we were providing for a reconnaissance with an asteroid, the ARM mission. So it didn't start out as Gateway. We actually transferred into the Gateway use case. And so all that systems level development that we had been doing was done largely internally. We had a lot of connections between the PPU and the thruster and the XFC, and they're very interdependent. They're related to each other. They highly impact the performance of the thruster and the life of the thruster. So it's very important to not only make sure that they all interface correctly, and we do that through requirements development, which is always difficult, but also through extensive development testing. Now, when we parsed out the thruster and now we're providing the thruster to Maxar, we are interfacing with Maxar's PPU and XFC. So that integration work was now transported from a largely internal endeavor to now company to company. And over time, NASA's been a great partner in trying to facilitate that integration work, making sure that we can speak directly and work directly with Maxar. I see some of those integration people in the room, so thank you for that work. It has really enabled us to establish what are the key critical parameters of either operation, how we operate the thruster, what kind of power gets delivered to the thrusters and the characteristics of that power, and making sure that it'll enable the thruster to fly with stability and robustness and meet our lifetime requirements. We have tens of thousands of hours that will be demonstrated on this thruster and qualified on this thruster. That is a long duration, and so we have to make sure that our interfacing is very well established. So I think that's something that NASA did really well for this particular program. A lot of collaboration, a lot of back and forth, a lot of give and take between the two teams, and that enabling us to directly interface with Maxar and make sure we're resolving that. On the cons side, so I think the main thing I wanted to highlight is how we do risk management. I come from systems engineering, was my original background, and risk management can be looked a lot upon as just another tool we use, another database we look at, another metric, but it has a lot of utility because it can really drive how we do decision making. And if you think about when we originally went to the moon with the Apollo missions, there was a lot of risk management going on, of course, because they were moving at such a high velocity, such a high speed, year after year, establishing milestones and really driving before they might have been ready, but they used a risk management process to make sure that they could keep going. And we largely had no issues, of course, except for Apollo 1, and we were able to bring everybody back safely. So how can we leverage that kind of thought process into our modern reach for the moon and other programs that we have? I think this is kind of an industry challenge that we can look at, not just a NASA challenge, but how do we make sure that every day when we're making decisions, because essentially it's just decision after decision as an engineer, that we're using a risk management process that is more standardized, that is easy to tailor to whatever issue you might be looking at, but also able to allow people to communicate their concerns and how we burn down that concern, so that on the one hand we're not making stupid mistakes, we're not causing big catastrophic issues, but on the other hand we're able to move with velocity, we're able to keep pushing forward in a fast-paced way, because we've already said, hey, this is certainly a risk, but it's not a risk we're going to stop for, or it's not a risk we're going to increase program cost or schedule for. So I think finding that balance as an industry is something we can really work on for commercialization.
All right, thanks for all those thoughts and comments there. Let's go ahead and open it up to the audience. I think I was pretty easy on them, so you've got some license. Go ahead. Yeah.
Jeff House, curious what challenges you faced working on PPE and Halo after NASA made the decision to co-manifest them rather than launching them separately, and what you have done to overcome any issues that have arose in technical, programmatic, or otherwise.
I'll start with that. So that is a good question. And one of the things early on that NASA encouraged us to do Northrop and Maxar is to work directly together, collaboratively. We all understood that there were going to be technical challenges associated with this level of change. And so I would say NASA's encouragement in enabling us to work together as partners, not as vendors or not as providers, but as true partners, has helped us make the technical decisions that need to be made to keep things moving at the pace that we need for it to move to launch when we want to launch. So.
Yeah, I could add to that. I think the good part of that was it really did force Maxar and Northrop to start talking earlier in the whole overall process, which would have happened eventually, but it kind of forced it a little sooner. And it also brought in the third party, I think, with the launch vehicle provider. And I think that, the three top technical issues, I don't know, I'm not involved in on a daily basis, are probably mass, and mass. When it comes to, putting two vehicles onto one launch vehicle, mass now became the top issue, obviously. But the team has been working on that for quite a while now. But I think overall it was a good decision. It really burns down a lot of risk if you think about it, delivering two vehicles to cislunar space and then having them having the rendezvous and dock together and hope that all works. That really, bolting them together on the ground is certainly greatly reduces risk.
At first, I thought that Jeff was asking me. I had a flashback. I think he might have asked me that once before.
Yeah.
So, all right. Thanks.
Hi, Rob Furl from the University of Florida. As a scientist, I represent one of the consumer side of the vehicle that you folks are talking about now. The Halo and the Gateway concept present to the scientific community an incredible asset that is basically beyond the term innovative. So my question to you folks as the developers of the system now, back in the day when Halo was being discussed and Gateway was being thought up, there were a lot of science requirements as part of the documentation and the reason for being. Can some of you, perhaps on that side of the dais there, speak a little bit to how science requirements and science capabilities are still existing within the design and implementation phase here?
I can take a guess. I don't know the requirements very, we're in the subsystem levels where we live, but I think I can maybe extrapolate an answer of some degree here. I'm still looking, and I think the first couple science experiments, for lack of a better term, and that's not the right term, but the first investigations are really radiation based and they're human health oriented, which they should be, right? If we're going out any further, we need to start understanding these gaps that were maybe in a roadmap that we didn't fully close. And so I still see this as similar to ISS in that, there's going to be some opportunities for some research dollars to fill in some of those gaps for NASA, but I think it's going to be a stronger commercialization component. I think that commercial space is going to have a stronger role in this potentially, and I think that's kind of exciting because that's where, as I was talking earlier, maybe some of the innovation, and NASA steps back a little bit and says, okay, make sure we're safe and we can have this continuing throughput for these types of investigations. I think that's where the value starts to come in. Did I answer kind of where you were headed, or? No? Okay. I'm afraid I'm at the end of my rope then. So if anybody else has got any ideas.
I'm not sure I could add a whole lot, but remember that we receive the requirements from NASA, so they're baked in there for science and for investigations, obviously. And I think the ISS is a good analogy in that in the early days of the ISS, science was somewhat limited because we had to get the vehicle up there and keep the crew alive and healthy and happy. But science is baked into the requirements, I know that. And now I think that's a more appropriate question for NASA to see on these early missions what the science investigations are going to be. Off the top of my head, I don't have them memorized.
Yeah, I would add to that just to reinforce here. The requirements are the requirements, and we understand that science is a huge driver of why Gateway is desired and the value that it's going to add. And so we don't distinguish between science requirements versus commercialization requirements versus integration requirements. They're all requirements, and as an integrator, we treat them all with the utmost importance.
say maybe on a more micro level with the EP thruster itself, like we said, we're going to learn things about the thruster, and the more data we have on that thruster, the better. However, because we're trying to make this into more of a commercial endeavor, drive down cost and schedule with fitting onto the PPE module, and you can't always get what you want, but if you try, you get what you need. So we are getting some data, but we're not getting all the data we would like, and we're going to have to make those kind of compromises. We can't get everything that we need to fully characterize a robust, like we're not going to do plume sweeps in space as much as I'm sure that many people would love to be able to do, or get some diagnostic data. We will get the basics, and we will be able to use that data to correlate the basics, and it will help us keep pushing forward on the technology. I think with GRC folks on the NASA side and on the AR side, the more data we can get on these thrusters, the better. But we will use what we can to keep developing the technology and moving forward.
Yeah, I kind of feel like with the pointing to that side, I was directed not to respond or stick my nose into it, right? But for the folks that know me, you know how I respond to shut up. So I'll just tell you, right? So I used to manage PPE on the NASA side. I know Shahab Chowdhury, the current project manager, I think is right here. And Joel Kearns will be here tomorrow. I haven't seen Joel yet, right, from SMD, but he's the NASA interface with ESDMD about science requirements. I can tell you at the module and integrated gateway level, science is still significantly driving the requirements. I'll give you a couple of examples. Right, so Rick mentioned mass, right, with co-manifest. You bet mass is an extreme challenge, and yet we are launching science payloads, right? And I personally had those conversations with Dan Hartman about, hey, here's the other stuff we're not gonna have, or how we're gonna try to carve more mass out. And these science experiments, we might be able to bring them up later, right, the whole discussion, and it was very clear, right, there's an international partner interest, there's the science community interest, right? And Gateway's about science right from the beginning. And so we're launching with those science payloads. Another example is in terms of the power management on the integrated vehicle. From a PPE perspective, we wanted as much power as we could have for orbital transfer, right? And even in the transfer matrix about, hey, yeah, we're going to be EP active at these times, there's still a significant power demand, both crewed and uncrewed, to support the science. So I was thoroughly impressed and continue to be impressed about, originally it was Dan Hartman's personal commitment and Gateway's programmatic commitment to making sure that it is science relevant right from day one. Oh, yeah, another question. Probably the last one here. Yep.
Okay, so my question is for Ms. Blackner, as the only woman on the panel. Being the chief engineer for such an important part of this mission with the Gateway satellites, how do you kind of navigate that as a woman in STEM, especially sorry, but this is a very male-dominated room, so just kind of how does that play a role into what you're doing?
Sure. Well, I don't actually know the genders that these folks identify as, so I might not be the only woman up here. But anyway, it's a Seattle joke. Let's see. So I actually got the opportunity to interview Poppy Northcutt last week, who you may know is the first and only woman that ended up being in mission control for the Apollo missions. And she happened to be in mission control as a fluke. She was actually in the flight software group designing the return to Earth trajectory for the Apollo astronauts and in her team. And she was stationed in mission control because they were working at such a high speed in their development and implementation. As you might know, Apollo 8 was originally an Earth orbit mission, and then it got changed to go for a moonshot because of pressure from the Russians. And so she was in mission control because she had to work directly with the retro officers to implement the code and make sure it was being done correctly in kind of real-time control and uploading or telling the astronauts what to control the computers to on board for their trajectory. Anyway, she inevitably got a question kind of similar to this one, and part of it was, do you ever feel like the outcast in the room, or like you're different, or at any point in time was it disruptive to you? And she said something very wise and something that I try to live by as well, which was, you could choose to let it bother you, or you could choose to say, I'm here, and we're going to keep working. And I've chosen the latter, and I think most women who end up, or people of color, or people who don't look like others in the room who are successful, usually end up doing something along those lines of, I'm just going to keep moving, and if you can't deal with it, then that's your problem. I will say that working on specifically this program, I think whenever I work on science missions, development missions, that I tend to work with very fair-minded people, people who maybe they recognize me as a woman, and I hope they do because they have eyeballs and can see and have judgment, but don't put limits on me and what I am capable of, and just allow me to do my job. So I think some of those people are in this room, so thank you very much for being advocates and allies for me and people like me. And really that's all it is. It's just keep going and choose to ignore it.
All right, that's a good question to end on. Right, so thank you again. Please help me thanking our panelists. It was a really good session. Thanks.